In this video, we are going to solve some quadratic equations by factoring. The standard form of the equation is ax squared plus bx plus c equal to 0, which means that on the left we have a trinomial, a quadratic trinomial, and on the right we have 0. So this is the standard form. If we have three terms of the trinomial, they must be at one side of the equation, and the other side of the equation will be 0. To solve such equations, we have to use the zero product principle, which states that if the product of two numbers is 0, then maybe a is 0, or maybe b is 0, or maybe both are 0. For example, if a is 0, we have 0 times b, which is 0. When b is 0, we have a times 0, which is 0, or maybe both of them, they are 0. 0 times 0 is 0. Now we are going to apply this principle to solve some quadratic equations in the following examples. So the first case will be when we have all the three terms in the equations. Okay, so again, the three terms of the trinomial, because we know this trinomial and we know how to factor it, so they must be on the same side, okay? And this method is by factoring, which we have to use now the knowledge that we have about factoring trinomials, okay? Now, the first example, we want to solve x squared minus 3x minus 18 equal to 0. As you see, the left side of the equation is the trinomial in the form x squared plus bx plus c equal to 0. Now, what is the idea of solving by factoring? So we are going to factor the trinomial, and we know how to factor. This is factoring as x plus a, x plus b, where x are the factors of x squared, and a and b are just two numbers that will satisfy the product c and the sum b. So we know this. And then we have to use the zero product principle, which states that if we want this statement to be true, x plus a times x plus b to be 0, then x plus a may be 0, or maybe x plus b is 0. So here we are leaving each factor equal to 0. Okay, and then we solve each equation. We subtract a to both sides, and we see that x is equal to negative a. And also here we solve the second binomial, x plus b equal to 0. We add subtract b to both sides, and we get x is equal to negative b. Now, this is very good because as soon as we finish factoring, then the solution is just the number that we have here, but in the opposite side, which means that this number is going to the other side of the equation. It is a negative number. So let's see this during the work. And here, as soon as you factor, so the solutions are the opposite sign of a, the opposite sign of b. Okay? Now let's see this during the work. Now, I want to solve x squared minus 3x minus 18 equal to 0. So I want to factor the left side. The left side is the trinomial that I know how to factor. So the first factors of the binomials will be x times x, and now I need two numbers. What are those two numbers? We know that the product of the numbers is negative 18, which means numbers have different sign. Okay, and now what are the factors of 18 that will satisfy the sum? Negative 3. So this is telling us the largest will be negative. Okay, now 18 is 6 times 3. And 6 minus 3 is 3. So these are the numbers. Let's place them into the binomials. So I will place 6 here and 3 here. Now I factor it. And after I'm factoring, I'm using The zero product principle that says that maybe one is 0 or the other is 0. Now, if you want, you can skip this step just to write x minus 6 is equal to 0. Let me write now. I will leave one factor equal to 0, and the first factor is x minus 6. Or x plus 3 is equal to 0. As soon that you use the zero product principle, now you know the solution. What is the solution? The different sign. So you have negative 6 here. You can say x is 6. Just change the sign. And here, x is negative 3, the opposite, okay? Or you can go and solve now. Again, as soon as you leave each factor equal to 0, x minus 6 is equal to 0. This means that we are using the zero property. Using this fact, this is general fact, so just change the sign and you have the solution. So this was negative, here is positive, this was positive, and now it will be negative. Okay, so, or you can solve this two small equation, adding 6 to both sides, and you know that this is positive 6. Or here, subtracting 3 to both sides, and you know that this is negative 3. Okay, so you can go directly, just changing the sign, or you solve these two small equations. Now let's go to another example. Example 2. So I want to solve the equation x squared minus 8x equals to negative 12. Let me rewrite the equation again. I have x squared minus 8x equal to negative 12, but this is not in the standard form. What is the standard form? The standard form is when I have a 0 to the other side of the equation and all the three terms at one side of the equation. So this negative 12, it is separated from other terms. So what I have to do? I have to send it to the other side. How? By adding 12 to both sides. And now on the right I will have 0, and all the three terms will be on the left. Now what is the mistake the students always do? You cannot combine terms that are not like. Here you have x's and here you have just a number. You cannot combine, but just rewrite. And recall why you added 12 to both sides, only to have three terms on the same side. So I have negative 8x plus 12 equal to 0. And now what I'm doing? I'm rewriting again the left side, which is the trinomial that I want to factor, into two binomials. And now I know the first term is x times x, and I need two numbers, and for this I need the factors of the product. Product is positive, same sign, both negative. What are the factors of 12 that will satisfy 8? They are 6 and 2. So negative 6 times negative 2 is positive 12, negative 6 and negative 2 is negative 8. Ready to place them into the binomials? So I will write negative 6 here, negative 2 here, it doesn't matter. And now I will use the zero product property. So I will leave each factor equal to 0. X minus 6 equal to 0, or x minus 2 equal to 0. And when I do this, I know that I change the sign and x is 6 and here x is 2. Just changing the sign. Let me change the sign and then I will solve the equation. So x is the opposite, 6. And here x is the opposite 2. Okay? Done. Or you can add 6 to both sides, solve these equations, and you know now that x is 6. And here add 2 to both sides, and you know that x is 2. Now, even though that we solved the equations, so we have to check the solution, okay? So let me check the solution for this example too. So for the other examples, I will not check. I will leave in your hand, okay? Let me check the solution now. As soon as you get two solutions, as you see, we have a second degree equation. Sometimes we get two different solutions, sometimes we get the same solution. So you'll see in another example. Now, let me check the solution. We know what is the job of the solution. The solutions makes the statement true. Okay, so what is the original statement? The original statement is x squared minus 8x equal negative 12. And I have to check both these values of x. X squared minus 8x equal to negative 12. Always when we check the solution, we check at the original statement. Now I have to replace x with 6 and with 2. Okay, so 6 here and 2 here. And now I will check if the left side will become negative 12, because if the left side is negative 12, then this is true. And here, the same thing. So now I am asking. So what I have here, 6 squared, 36, minus 8 times 6, 48, and 48 minus 36 is 12 with a negative sign, because we subtract from 48. As you see, we have negative 12 times negative 12 true. Therefore, 6 is a solution to the equation. And what we have here? We have 2 squared 4 minus 8 times 2, 16. And we know subtract from 16. 16 minus 4 is 12. Negative because we keep the sign of 16. So the left side becomes equal to the right side. True statement. Therefore, 2 is a solution. Okay, therefore, the solutions to the equation are 2 and 6. That's it. Done. Okay, so I check this example too. You can check all the other examples, okay, but I'm not going to check. I'm going just to solve. Now let's see example 3. So solve x squared plus 6 equal to negative 9. Okay, let me solve this. So I have x squared plus 6 equal to negative 9. This is not in the standard form, so I'm sending 9 to the other side by changing the sign into a positive. And on the right will be a 0. So x squared, sorry, this is 6x. Okay? So plus 6x plus 9 equal to 0. So here I worked a little bit different. Okay? What I did here, now this was, so I added 12 to both sides, and this is the same thing that I am doing. I am adding 9 to both sides, but I'm working a little bit faster, and I'm saying just I'm sending -9 to the other side by changing the sign. Because if you change a side, you go to opposite side, you have the opposite sign, okay? Now, I can recognize this. This is a perfect square trinomial. Why? Because I see that the base of x times the base of 9, which is 3, 3x times 3, double it, is 6x. So this is perfect square, so I can factor this as what? As the square of the binomial when the terms are the basis of the first and the last term. So with a plus x plus 3. Okay? So now I can take the square root of both sides. And when I take the square root, let me take the square root of both sides. And now what I have x plus 3, because 2 here, they simplify. I have x plus 3 equal to 0. So directly I can say here that x is the opposite sign, -3. Now, or you can subtract 3 to both sides, and you know that x is -3, and this is a double solution. Okay, so we have two solutions, but this is the same value, okay? And I will explain you why. Now it's time to introduce you to the graph of this equation. So I will take these two examples. So I had example 2 is to solve x squared minus 8x equals to -12. And the second, this was x squared plus 6x is equal to -9. Okay? Now, here the solutions were 6 and 2. Let's see. They were 6 and 2, and here the solution is a double solution, x minus 3. Two and 6, and here x was -3. Now, what is the graph of the solutions? The graph of the solutions is a curve that will cut the x-axis at exactly when the value of x is 2 and 6. And the curve is a parabola, like this. So this is the x-axis, and these are the solutions. When x is 2 and 6, the parabola, the graph of the equation, cuts the x-axis. And for this case, okay, x is -3. The parabola only touch the x-axis at x -3, like this. Okay, so this is the meaning of our solution. Sometimes, if we try to solve and we cannot solve the equation using real numbers, the graph will be like this. For example, the parabola never touch the x-axis. Okay, so there are no real solutions. So just what the solutions mean geometrically, we'll go to learn later how to graph the solution set of a quadratic equations. Okay, but today is not the it is not the subject. Today we just want to solve, just to find the solution, and that's it. But since we have a double solution, okay, so you have to know what this means. Now let's go to do example 4. I want to solve the equation x squared plus 36 equal to negative 13x. So as I see, this is not in the standard form. I need to send negative 13x to the other side. Let me rewrite it again. X squared plus 36 equal to negative 13x. I will send 13x to the other side by changing the sign, and it will be positive 13x, and there I will have a 0. Okay, so let me rewrite now. X squared plus 13x plus 36. And now let me rewrite again. X squared plus 36 plus 36. Factoring equal to 0, okay? So again, I have x squared plus 13x plus 36, and I want to factor. I know the first term is easy, xx, and now I need two numbers, and this product, positive product, means the same sign. Both numbers are positive. So what are the factors of 36 that will give me 13? And they are 9 and 4. And now my job is to input them into the binomials, and I have positive 9, positive 4. Now I will use a 0 property. I will leave each factor equal to 0, x plus 9 equal to 0, or x plus 4 equal to 0. And immediately I have the solutions. So what are the solutions? Here the solution is the opposite sign, negative 9. And here the solution is the opposite sign, negative 4. If you are not satisfied like this, you know what to do. You subtract 9 to both sides and you have the solution. And also here. But you don't need to, since we went before into the general form, and the general form told us that just change the sign if you have two factors, and after you leave them to 0, just change the sign and they are your solutions. In other words, the solutions are negative 4 and negative 9. So let me go and do another example, example 5. So x squared minus 15 equal to x. Solve it. Okay, so I want to solve this. It is not in the standard form. So x squared minus 15 is equal to 2x. I will send 2x to the other side by changing the sign. It is positive. And this will be 0 now. So what I have on the left, I have x squared minus 2x minus 15. Let me rewrite this again. X squared minus 2x minus 15. I want to factor it and let it equal to 0. So the first are xx, and now the numbers are negative product, different sign. The largest will be negative. So negative, positive, and now what are the factors of 15 that will give me 2? They are 5 and 3. So negative 5 times 3 is negative 15, negative 5 and positive 3 is negative 2. So negative 5 will go here and positive 3 here. Very good. And now I will leave each factor equal to 0, or x minus 5 equal to 0, or x plus 3 equal to 0. And immediately now I have the solutions. So just change the sign. X is 5, positive, or you add 5 to both sides. And here x is the opposite, negative 3, because you have to subtract 3 to both sides. Okay, that's it. So the solutions are negative 3 and 5. Done. You don't need to write the phrase. The solutions are this and this. Just show me this and you are okay. Example 6. So let me introduce you now to the second case. X squared minus 5x equal to 0. So this is the second case. The constant is missing. Case 2. No constant, which means it's easier to factor. Okay, so let me solve this. So since I don't have a constant, the factorization is very easy. So I want to solve x squared minus 5x equal to 0. Both terms are in the same sign, and this is very good. No constant, it doesn't matter. Better for us. So what they have in common? They have x in common. So I factor out x, open parenthesis, what is left? From the first term is left x, from the second is left 5. Check x times x squared, x times negative 5x equal to 0. Use the 0 property. So maybe x is equal to 0, or x minus 5 is equal to 0. So right away we have one solution, and here just I want to change the sign, and that's it, I'm done. So why I change the sign? Because in my mind I added 5 to both sides, or I send the negative 5, as I said, by changing the side to the other side. Now, that's it. The solutions are, you don't need to write it, just leave it here, check it, and I know. The solutions are 0 and 5. Example 7. Solve x squared plus 7x equal to 0. Solution. Happy again, no constant. So x squared plus 7x is equal to 0. I will factor the common factor, which is x. What is left? X plus 7 equal to 0. Now using the zero product principle, we say that maybe one of the factors will be 0 or the other, so x is equal to 0 or x plus 7 is equal to 0. Straight away I have a solution. X maybe be 0 or the other factor. And here I have an extra step just to change the sign, and x is negative 7. What I did here, I subtracted 7 to both sides. The solutions are 0 and negative 7. Example 8. I want to solve x squared is equal to 11x. Now I see that my terms are not on the same side, so I have to remove 11x. So I have x squared is equal to 11x. So instead of subtracting negative x to both sides, I am doing this in my mind. I'm changing the side of 11x by changing the sign. And this is gone. And now here I have 0. And here I have x squared minus 11x. And now I'm factoring x outside. Here is left x, here is left negative 11. I'm leaving each factor equal to 0. I have right away one solution, x is equal to 0, or x minus 11 is equal to 0. And now, here I have just to change the sign. It is negative, will go positive. Why? Because I am adding 11 to both sides, or sending that to the other side by changing the sign. So, I have two solutions. Let me make this with red. So done. Example 9. Solve 6x squared minus 9x is equal to 0. So this is in the standard form, okay? Let me rewrite this again. Both terms, even though the constant is missing, both terms are on the same side. So remember, all the time that you use factoring, you need one side of the equation to be 0, okay? So let me rewrite now 6x squared minus 9x is equal to 0. I have to factor the common factor. Now I have a common factor. 6 and 9 are divisible by 3 and x. So 3x is the common factor. Open parenthesis, write what is left. 6 divided by 3 is 2. From 2x's, 1 is outside. 2x minus 9 divided by 3 is 3. X is outside. Close, equal to 0. Now what is the job? To leave each factor equal to 0. I have 3x equal to 0, or 2x minus 3 equal to 0. And now I know that x must be 0 in order to multiply with 3 and to give us 0, but doesn't matter. I'm dividing by 3 both sides. X is 0 because 0 divided by 3 is 0. Now, we are using the 0 property. We know that x must be 0 because 3 is not 0. So how a product becomes 0? If one of the factors is 0. So x is 0. But doesn't matter. You can continue slowly. So one solution. And now here I have to solve this because it is not the case, just x and a number. Now I need to solve. I am adding 3 to both sides. So what is left? It is left 2x is equal to 3 divided by 2 both sides, and x is equal to 3 over 2. The other solution. So sometimes you need to solve the equation, sometimes not. Done. The solutions are 0 and 3 over 2. Example 10. I want to solve negative 5x squared minus 15x is equal to 0. Let me rewrite the equation. Negative 5x squared minus 15x is equal to 0. Standard form, one side is 0 because I'm using factoring. Let me factor the common factor. So I had negative sign in common. 5 and 15 both can be divisible by 5. X in common, the smallest exponent. So negative 5x is the common factor. So what is left? So negative 5 is outside. From 2x's, 1 is outside. Is left only 1x. 15 divided by 5 is 3. But be careful. The negative sign is outside. So it is a positive 3. Okay, or you can say negative 15x divided by negative 5x, but you don't need to. And now, be careful again. If you factor the negative sign outside, this is left positive inside, this is left positive inside, okay? Now, let's leave each factor equal to 0. Negative 5x is equal to 0, or x plus 3 is equal to 0. And now, here you can divide by negative 5, or right way you can say that x is 0. Knowing the 0 property, you know that 1 must be 0 to be multiplied with 5 and to give you 0. And here, immediately you can change the sign. Or just subtract both sides, and you know. Now, the solutions are negative 3 and 0. Now case 3. And here you have the choice to work by factoring or by the square root property, but I have to introduce it to you. So solve x squared equal to 49. Now here it is missing the x term, and this is good. So as you see, you have x squared, you have the constant, but you don't have the x term. Recall? So you have x squared, you have the constant, but you don't have the x term, and this is very good. Okay, because why to use factoring when we can use the square root property? Okay, I am doing the first one with the two methods. Let me do factoring here, and then I will use the square root property. So let me solve. So the equation is x squared equal to 49. If I want to use factoring, I need a 0 at one side, so what I'm doing, let me subtract here 49 to both sides. You can send it to the other side, but doesn't matter. So it is x squared minus 49. And now I have the difference of the two squares. X squared minus 49 is 7 squared. So I know how to factor this. This is 1 with minus and 1 with plus. I am factoring the square, the difference of the two squares. And now what I have to do, 1 minus 1 plus, just write the basis. X, 7, x, 7. Check, x times x squared, 7 times 7, 49, with a minus between, equal to 0. Now, I have to leave each factor equal to 0, x minus 7 equals 0, or x plus 7 is equal to 0. And now I can change the signs, and I'm okay. So x is positive 7, or x is negative 7. Or you can add 7 to both sides, and here you can subtract 7 to both sides. Okay? Now, let me repeat this with the square root property, and you'll see that if the x term is missing and you have the square and the constant, the other method works better than this. Now let me repeat it. Let me introduce you to the square root property. This property is saying that if x squared is equal to k, where k is a real number, then x is equal to plus or minus the square root of k. Okay? Where k is any real number. In other words, we know that a positive number, because k is a positive number since it is the square of x. So k is a positive number, and we know that any positive number, for example 9, has two square roots, because 9 is 3 times 3, and 9 is also negative 3 times negative 3. So when I am looking for the square root of 9, okay, we discussed this when we work with numbers. So this is telling us that by words, when we say what are the square root of 9s, we say the square root of 9s are positive 3 and negative 3. But when we write the radical sign, this is asking you only for the positive root. And if you want the negative one, we put a minus in front just to show that we want the opposite of the positive root. Okay? So here are both roots, and combining them together, if we put plus and minus, okay, in front of the radical sign, which is the square root of 9, we are looking for both roots of 9, which are positive and negative 3. So we discussed this. You already know this stuff. but it is not bad to recall them. So this is the square root property. Let me put this. Okay, and now I am using this. If x squared is equal to k, then x is plus or minus the square root of k. So these are not plus and minus, these are the signs of the square root. Positive and negative square root of the square root of k. Okay? Now, what was the problem? Our problem was solve x squared is equal to 49. So I'm not using factoring, so this is the best way. X squared at one side and the number to the other side, as the property said. So for this problem, no factoring. And now what I know from this property, if x squared is 49, then x is equal to positive and negative the square roots of 49, both roots of 49. And so x is equal to positive and negative 7. So here we have both solutions. We don't need to write them separately. Or you can say solutions are, but this is enough. This is talking. Math is talking in symbols. You don't need to rewrite. But however, solutions are, because they are different numbers, negative 7 and positive 7. We know that they are different numbers because the signs tell us that they are different numbers. Now let me go back and see how much time we saved by using this property. So here, okay, what we did, to use factoring, we need 0 at one side. So we subtracted 49 in order to have all the terms that are in our equation at one side in order to use factoring. And then we use the formula how to factor a difference of the squares. And then we left each factor equal to 0, and we have two solutions, negative 7 and positive 7. By using the square root property, we need x squared at one side and 49 to the other side, which means x squared at one side and the constant to the other side, because this is the form of the equation when the x term is missing. Just keeping this in mind. We don't have x term, no x term here. And we are happy when we see this. So, let's go now and do another example using the square root property. So, this is example 12. So, this was example 11. And now we are going to do example 12. Example 12. Solve x squared minus 16 equal to 0. Okay? So what is it missing here? The x term is missing here. I can use factoring by factor this as a difference of two squares because 16 is 4 square. But why I prefer to use the square root property. For this reason I have to move 16 to the other side, and now I have x squared equal to 16, and I know if x squared is 16, then x is equal to both roots of 16, positive and negative the square root of 16, and x is positive and negative 4. And here are both values of my solutions. So therefore solutions are negative 4 and positive 4. Done. So here I needed to move 16 to the other side in order to use this property. Or I can use factoring. X squared minus 16 is 0. And I can factor this as the difference of two squares, one with minus, one with plus. The bases are x and 16, or x squared is x times x, and 16 is 4 times 4. Leave each factor equal to 0. X minus 4 equal to 0, or x plus 4 equal to 0. And now just change the signs. X is 4, and here x is negative 4. and still we have the solutions. Okay, so I change the sign, or you can add 4 to both sides. Okay, now I'm going using the square root property because you know factoring already. This is a new thing. So example 13. I want to solve 4x squared is equal to 81. I am happy again, so I don't see an x term, and x squared is at one side and the constant is to other side. But now I have a coefficient of x squared, but I don't worry so much because the first step is to divide by 4 and to leave x alone. So 4 divided by 4 is 1, so I have x squared is equal to 81 over 4. They cannot be simplified, okay? But as I see, they are beautiful numbers because they are square numbers. Now, if x squared is this number, then x is equal to the positive and the negative root, the square root of 81 and 4. And happily, I declare that these are, the x values are positive and negative 9 over 2, and I'm done. Okay? So therefore, let me write the solution. The solutions are, you don't need to write it, the solutions are negative 9 over 2 and positive 9 over 2. So don't give an answer a decimal number, okay? Because these are exact numbers, these are beautiful numbers that we call rational numbers. So they are in the simplest form, and this is good. Now, example 14. I want to solve 2x squared equal to 18. Solution. Let me write, I am happy because I don't see x term, and x squared is at one side and the number is to the other side, okay? So the first thing, I have to divide by 2 both sides, and x squared is 9, and now x is equal to the negative and positive, the square root of 9, which are positive and negative 3. Done. Okay, so these are the solutions to the equation. Now let me do the last example. Example 15. Solve 3x squared minus 21. Okay, now I want to solve this equation. I am happy when I see that there is not an x term there. And now I will send this number to the other side by changing the sign. It is the same that I am adding 21 to both sides, and this is gone. So what I have 3x squared equal to 21. Dividing by 3 to both sides, x squared is equal to 7. And x is equal to positive and negative square root of 7. I don't know the square root of 7. 7 is not perfect square number, and the exact solutions is this. Let me write the answer for this. The solutions are the negative square root of 7 and the positive square root of 7. That's it. Done. This was the lesson for today. Okay, we finished the solving quadratic equations in one variable x by factoring. So see you next time on the next video when I will talk about the property of the square roots again, and working with radicals, okay? So we have a lot of work in front of us, so please, do the homework about this topic, because the next lesson will be more complicated and we have to work more. Thank you very much that you are listening to me, and be prepared that we will go to work with radicals. Thank you very much again.